So we have an employee, department, project, and the dependent. Among this entity type or entity, if we cannot find the key attribute, let's take a look at the employee. It has a social security number, so it's underlined. It's a key attribute. Key attribute is the attribute that can be used for identifying specific data, specific entity. So similarly, department has two keys. So key attribute name or number. Also project has the number, so underline. However, dependent, it can be used for the key name. However, we may have the conflict name from the different employee. So we cannot use the name solely as a key. Instead, we need to use the employee corresponding, okay? Or the identifying the entity employee. So at that time, this is called the weak entity. In case of weak entity, we are going to use the word, the rectangular, and also the corresponding relationship is called the identifying relationship. So next class, when you practice the EI diagram to draw, so sometimes you may realize you cannot draw the identifying relationship. Okay, when you create the identifying relationship, it can be automatically change the other, but it doesn't matter. Okay, then we identify entity or entity types first, and there the attribute, also the key attribute. It's not required to have a key attribute during the EI modeling. Okay, EI modeling is not computer modeling. It's just conceptual modeling. It's a logical model. It can be used for your real life. So think about when you classify your stuff. You don't want to mix all different subjects in one bin. So sometimes you can purchase the basket, 5 baskets. One basket is used for the database. Another one is used for the operating system. Third one is used for different one. Which means you are going to collect the similar or the same stuff for the one. It's the same idea. So we can collect the same information, same entity for the employee and so on. Okay. Also, that doesn't have to be unique, right? So that can be, you may have the same material in the same bit. So it doesn't matter. So even you can search, but you need to check all the stuff. But database is different later. But in the ER modeling, it doesn't matter. Sometimes you may not have. So that is entity. There are 3 different types of attribute for your remind. One is just a normal attribute. That is for example, the birth date, address, salary, and sex, and so on. So we can use the over to represent. And another type of attribute is a composite attribute like the name. In this case, the name can be segmented into the first name, middle name, initial, last name. At that time, we can keep using the sub-attribute. Okay, it's like the tree structure. Third one is if you take a look at the locations, it's different from the location in project. What is the different? It's a plural. This is a singular. If you take a look at the description of the company database, it's clearly mentioned the locations, a number of locations. But for the project, it's just a single location. We will see later. This is not critical when you are doing the general ER modeling. Okay, especially object-oriented modeling, it doesn't matter. But database modeling, later, database actually cannot handle multi-value. So that is the reason we identify the multi-value. We will see details later. Why relational database especially cannot handle multi-value. Okay? So that can be represented by the double over. Then that's pretty much okay entity type, entity. The next step is relationship. So, or the relationship type. It's the same thing from the bunch of relationship. Like he likes her, she likes him, and the entity likes the entity. We can find such a relationship type. So, for example, works for one employee, works for one department. However, one department may have a number of employees, right? Because of that, each relationship has cardinality. 1 to 1, 1 to many, or many to 1, or many to many. only 3 different cardinality. Okay, so that is the many employee works for one department. Don't be confused. A lot of students first time confused and too many like that. Because one is if you draw the diagram, so employee, this is a department, employee 1, employee 2, employee 3, department 1, department 2. It's like this one. Right? It's like this. This is a many side, this is one side. But if you take a look at the entity of it's a many employees. So some of the students confused. It's a many to one like that. Okay? This is wrong. So many entities works for one department. So don't be confused. It's a many to one relationship. The next one is the where did I put the pointer? I just lost my pointer. Do you see my pointer? I have used here, but suddenly I hear. So that one-to-one relationship is if you remind the math class, so one element of a set map to the one element of the set, one-to-one mapping. So this is exactly the same thing. One employee manage of the one department. Also, one department is managed by another employee. Okay, so we can have the many-to-many relationship. So this is a cardinality. Another type of the relationship is this one. This is interesting, the relationship. One employee work on many projects, right? Okay, so I think that many of the students confuse the homework. So by next class, please bring the 1-page drawing of this ER diagram. Okay, it's a hand draw. Okay, so you don't have to use any computer stuff. Just the 1-page, the drawing, the ER diagram for your practice. Okay. Then it's a many-to-many relationship. So which means the one project has the many employee, and also one employee works on the many project. It's a many-to-many. Yes.
So in some entity relationship, we have double line and a single line.
Yes, I'm going to explain. I'm going to go for that also. So that is the next thing. But before that, this is important. If you take a look at the relationship, we are using the rhombus to represent the relationship type. So works on. But this one, manager has the start date attribute. Works on has the hours attribute, which means relationship type can also have attribute. Okay, but especially many-to-many case, it definitely has the attribute. If you take a look at the manager is like the this one, right? One-to-one mapping. So it has a start date. It's okay. You can put this attribute to the employee side. It's okay. And or you can put this start date to the department because it's one-to-one mapping. It's the same, the relationship. However, in case of the work zone is like this one, many-to-many. You cannot put the hours here because you don't know how many hours work on each department. Vice versa. For each department, for each project, I have a number of employees. I do not know how many hours for each the employee. Because of that, these hours should be attribute of the relationship. This is a very important part, interesting part. So that's the reason it's connected to the work zone relationship. Okay. Then that is cardinality. Another, the characteristic of the relationship is the single line, double line. Single line means
Optional.
it's optional, which means employee is not always the manager. Some of them. However, department double line means mandatory, which means department must have the one manager. Similarly, what is the meaning of the double line here? Employee, when an employee is hired, should be department. okay, assigned to the department. Vice versa, when we create a new department, at least one employee, maybe manager, right, should have at least one. That's mandatory. This one is mandatory, this is optional, means I may not have any dependent, right? So that is the reason. However, be careful, this one definitely should be double line. I'm not sure whether you can say this is a double line. Why? If we have dependent, there might be employee who depend, right? So it's a double line. So double line and single line, they indicate whether it's optional or the mandatory participant. Another interesting one is the supervision. Most of the relationship has the binary, which means the two entity, relationship of two entity type. However, this one is an employee, supervise another employee. But we can just separate. One employee is used for supervisor. Another employee is used for supervising. Okay, supervisor, supervising, supervising. So it's still the binary relationship. Two entities, but they are same entity. So it's called the self-referenced relationship. And I already explained this one. The last one is the dot over, which is a derived attribute. Actually, this attribute, what's the name of the number of employee? We can count the number of employee of each department from the employee, right? Which means whenever we check the number of employee per department, we need to go to the department count. If I want to know the number of employee for the IT, I need to go to the IT department and count. It takes a time. Why not? Calculate, pre-calculate, because the employee is not much changing. How many times hire the employee? So every moment, every second, or so every week, or the month. So we can calculate to save the time, computation time. We can create such a derived. It's not critical, but you can add such a thing. So this is the form of the entity relationship. Pretty much benefit. It's easy. You already understand. So, but two more important thing is you should be familiar. So, first the homework. Okay, I think the most. Anyone who did the homework? Tanya?
Yeah,
Kind of.
No, like there's certain parts that I left. Like you see the double lines.
Okay.
Yeah.
So just to follow direction. Okay. So it's to be familiar with the ER diagram. So using the pencil and the paper, just following the step and draw the ER diagram this one. Okay. So for your practice by the next week. Not next week, next class on Thursday. Okay?
So, Professor, is this the same as the one where we have to write the description and also
Oh, that's
the
different.
diagram, or
Okay.
the same?
There's another homework is you need to find your own database
Yeah.
description. Or you need to create and create your own ER diagram. But that should be submitted to the Canvas.
That one is on
Yeah.
campus,
At that time, you can use any tool, drawing tool. PPT is okay, the video is okay. If you are familiar with the drawing tool, it's fine. If you believe that you don't have any skill to draw the diagram or so on shape, so last option is you can draw the handwriting, hand-drawn, the ER diagram, and take the photo and upload. But I suggest to use something tool. Okay? Then I will use one of your homework for the midterm exam. Okay, later. Okay, so let's continue this one. Sometimes, why don't you take a look at this? Your customer gave you the description, requirement of company database like that. For example, we need at least 4 employees per department. When we create the department, we need the manager, a vice manager, secretary, and administrator, like that, for the employee at least. So when you create the ER diagram, can you represent such a requirement in your ER diagram? Yes? No? So what we can do is one side or many side. Okay? One to one, one to many, many to many. Or single line, optional, double line, mandatory. We cannot specify very detailed requirement using ER diagram. So sometimes your customer may ask, or sometimes you realize that our database needs more specific information, cardinality of the relationship or entity at that time. So the traditional ER diagram notation is not good enough. So we are going to extend the change a little bit notation of the cardinality, that is called the min-max notation. Instead of 1 to 1, or 1 to many, or many to many, we are going to specify what is the minimum participation of this the relationship. For example, this is work on, work for. So minimum 1 department, maximum 1 department. The meaning is 1 employee work for only 1 department, always. On the other hand, the department side, the minimum of the 4 employee and maximum unlimited. Which means each department should have at least 4 employee for work for and maximum unlimited. So this is called the mean participation, maximum participation, so it's called the min-max notation. So using min-max notation, we can specify more details, requirement of the relationship. So for example, here, it was like the 1 to 1. 1 manager, 1 department. But if you take a look at the min-max notation, employees 0, 1 means what? Minimum 0, maximum 1. Minimum for each employee, 0 department manager. So a lot of employees, they are not manager, right? Some of them are manager. How many? 1 department manager. Vice versa. From the department side, minimum how many manager? 1 manager, maximum 1 manager. So don't be confused. This is 1 to 1 in terms of the previous notation, but it's not detailed. So if you want to specify the detail, the requirement, you can use min-max notation. What about the works for? Works for is many to 1. Do you remember? So this one is a many. Where is yes, many to 1 relationship. Okay, many to 1 relation in terms of the min-max notation. Don't be confused. It's a many side. However, min-max notation, participation, degree of the participation. So employee works for minimum how many department? 1 department. Maximum 1 department. From department side, department should have minimum 1 employee, manager, and it's unlimited. If you have the limitation, you can specify maximum 100, like that. So min-max notation is more details, the information when you need. But I have, in my experience, I never see the real ER diagram using based on the min-max notation. So if you have such a detailed, it's actually very strong requirement. So you can specify when you create the database. So you can specify, you can take a note in the ER diagram, or later we will see the relational database diagram. So at the time, the relational schema diagram, you can take a note and specify. Okay. Mostly such a requirement will be implemented by not database model, but application program. When you are doing coding, if the number of employees is bigger than 100, so it's a decline like that. So in the application side, but database side, the design you can do this. This is called the min-max. But this one is the confusing part. It's a many to 1. However, min-max notation different because min-max notation represent the degree of this participation. Degree of this participation to the relationship. Okay? This is a min-max notation. So we can change our ER diagram based on the min-max notation. You can see the let's take a look at the project. Works on, so 1, n means that from employee side, employee, minimum 1 project, maximum n project. It's a mandatory participation. From the project side, minimum 1 employee, and maximum unlimited employee. So it's a many-to-many relationship. Okay, so this is the min-max notation. So we can use the such a notation to represent the ER diagram. This is the one notation. It's not standard. So if you take a look at the different textbook, they use different notation, but intuitively you can understand. Okay, this is one of the popular notation. Another, the notation is a crowfoot notation. Crowfoot notation is, what is a crow? It's a bird, right? The crowfoot is like this one. It's a bird foot, right? I'm not sure whether it's a so it's a bird. It's a crow foot. So this side is what? What?
Foot.
So many sides. This side, one side. This is a crow foot notation. So some of the notation use the crow foot notation. You already know there's other notation like this one. This is a UML notation. So UML notation, you can see you can specify the min-max, the details of the min-max notation. But this one is slightly hard to understand one. Relationship. So relationship is here, but you need to specify like that. So hard to understand the relationship. But later, UML can be used if you are familiar with, but the UML is not used for the database design very well, because relationship is also the table later in terms of relational model. So we'd better clearly understand, identify such a relationship. But this is still possible also. And this is another possible diagram. Okay, couple of more things before we move to the chapter 4. So far, relationship has how many entities? 1 and 2. So which means 2 entity. So even though supervising employee, supervised employee, how many entity? 2 entity type. So it's called a binary relationship. So most of them binary relationship. But sometimes you may see the higher degree, more than 2. Later, let's take a look at the example. So this example is supplier. It's a group or the company or the person, supplier. Supply the part and supply this to the university. Okay? So supplier is one entity, so contractor. And item, part, is another entity. And the university, project. So 3 entities are involved for supply the relationship. Even more, okay? Sometimes the 1, 2, 3, 4 entity can be involved in one relationship. Okay? So at that time, this kind of the relationship is called ternary relationship. And so it's called the n-ary relationship. If you have the n number of entity type, but I never seen the 4. But the 3 is possible. I have seen the 3 in the real project. But intuitively, it's not easy to understand. You can understand eventually, but not exactly intuitively understand the meaning of that. So a lot of time, if you have such a ternary relationship, they'll change it into 3 binary relationship, which means I supply the item. Okay? I supply the item. That makes sense? And as a contractor, I'm contractor of the university project. Also, this project used this item. So you can change the ternary relationship into the 3. The binary relationship. That makes sense, right? One more time. So instead of the ternary relationship, we can change the ternary relationship into 3 binary relationships. 1, 2, 3. Okay? So this is one option. A lot of projects use such a binary relationship instead of a ternary relationship. Or another thing is, instead of supply the relationship, why not create the supply entity? So supply itself is the entity. You can consider supply itself is the entity, but supply does not have the key attribute because it was the relationship. So we can create a weak entity. Then create the binary supply, part supply, the project supply. Kind of, you can imagine this supply is the virtual entity you create. So supplier participated in this supply, and the part participate in this. Project participate in this. Then key of this is key combined. Then this will be the key of the supply entity. Like here, one question. So when you take a look at the A and B ER diagram, are they same or not? Are they equivalent to each other or something different?
We are having 2 relations there.
So we have 2 more relationship. Yes, that's different. In terms of modeling or in terms of data, yes? Relationship, just loud. It's okay.
We have 2 more relationship types.
2 more relationship types can supply and use. That's true. That's what we want. We can easily understand the meaning of a ternary relationship. Anyone? From the data point of view. Data. We don't want to keep when you model, when you clean up your room, we don't want to keep the unused, the item in my room, right? Whenever you find the unused, never been used, you throw away or give away, right? So database really hate such a, one thing is redundant data. When you have redundant information, what's the problem? All the data are same. All your book, your notebook are the same. What's the difficulty? It's hard to find. Some of the people like all the same clothes, all the same item, all the same notebook, but you don't know which one is operating system, which one is database, which one is, because it's the same data. You need to check each and everything. So database really hates such a redundant information. Another one, unused data. If data is not being used, why do you keep such a data? It's a waste of space, and it takes a long time to search your data. So we don't want such a unused, non-related data. When you take a look at these 2, it looks like the same or same meaning. However, for example, supplier supply this part. Okay, so it's used by project. So we can I'm the contractor of a project, so we can supply this part. However, I'm the supplier, but I'm supplying the pointer also, right? But this pointer is not being used, never been used by this one. It can be here. So even some of the additional, the information can be used here. Also, for example, I'm the contractor of the project, but I don't supply any item. I do not have any item. Then it's additional, it's unused, non-related information. So when you are using these 3 binary relationship, sometimes non-related information will be created. So you should be careful. So another question, can you guess? So if you are database designer, which one do you like? This one or this one? A or B? D? And why?
We can we cannot use the redundant data.
Yeah, if we avoid the redundant data, this one is easy. So actually no way to create the ternary relationship using database. Think about basically the data computer system is binary. So very familiar with close to the binary. But ternary relationship is not easy. So you need to find any way, different way to make the relationship. So database, specifically database model that we are going to use, a relational database model, cannot handle this one. Object-oriented programming model may be possible, but the relational model actually cannot do. So we eventually convert such a ternary relationship into this. So because of that, when you are doing the database designing, you may not see such a thing. But sometimes those who are not familiar with the database design, but the conceptual modeling, as I said, like the analyst or the account, those who are doing conceptual modeling, they can define such a relationship as a ternary-anary relationship because they do not know database. And your job is to convert this into such a binary relationship. We will see such an example later when we design the database model. Okay, so that's the ternary relationship. This is another example you can avoid to address the problem. So if we do not have this one, binary is additional. So we can add and offer, then create the relationship. It's too much the constraint. So I don't recommend this one. Such a thing. Okay. So this is another example of the min-max notation ER diagram for the universe database. So from the ER diagram, this is a ER diagram. Can you understand it's a kind of reverse engineering. So can you create the requirement of the university database? So in other words, can you write down the requirement of the university database from this ER diagram? Just try to understand kind of interpretation. I will give a couple of minutes. Just take a look at the ER diagram and try to understand what is the requirement of the university. If you can understand, if you can interpret, I think that pretty much you are done. You are ready. For example, this university has what?
6 entities.
6 entities. First, it's a kind of the suggestion. It's a kind of the pattern. When you create the ER diagram, most important part is starting from the top left corner because our reading is from top to bottom, left to right. I know. Arabic is from the right to left, or old Chinese, right to left, but the most of languages nowadays is the top to bottom, left to right. So we put the important. Important means what? Many relationship. So we have a number of college. So university has a number of college, and their dean is from the instructor, right? And instructor also chair of the department. The college has a number of departments. And specifically, the minimum 0, maximum n means some of the college does not have a department, right? But the department should be part of college. Then we can understand how the university is organized. And also, department has the number of instructor. How many? Sometimes may not, sometimes many. However, this instructor should be like that. We can understand the meaning of the university. And also, department can offer number of courses. And the course has a number of sections. Each section taught by instructor. Not the course, it's by the section. Then student can take the section. And also student is a part of the department. Then we can imagine how the university is organized and even operated. So this is the ER diagram. So ER diagram is not for database only, but it can be used for many applications and even in your real life. So easy way to represent your conceptual design of something in your real life. Okay, this is the university database. So this is the data model. However, this is my experience. When I joined the IT department the first time, 1995, it was a long time ago. So actually my major was the mathematics. So I didn't major computer science. I didn't know anything about the computer and computer science at the time, but I was hired as a database administrator. It's my first job, entry-level job. Even I do not know what is the database at that time, but my supervisor hired me, picked me up because my major is mathematics. We will see why later. So very closely related. So I assigned to at the time called the downsizing project. Downsize means what? Weight control. Downsizing, slim. Because long time before, computer system is centralized. So everything is one, the big computer. At that time, right now it's not such a big, but at that time it's a centralized computer system. So it's a problem. If you have more customer, more transaction, you need to replace the entire computer system. So why not? Like the people, the downsize, we can take out some part of centralized system to the what? So when were you born? So 1995, you were born. So, but if you check the history of a computer, 1990, middle of 1990, or the 2000, so what was the issue? So personal computer. Actually, personal computer started from the beginning of 1980. So like the Steve Jobs, released the first Apple, the 16-bit, 8-bit, and 16-bit computer, then fired, then come back, then he successfully back using the what? iPod, right? Then the iPhone, like that. So personal computer started from 1980, but it was really expensive, the personal computer. So at that time, even cost 2,000. So 2000, if I remember correctly, at the time the yearly salary normally the 10,000 or 20,000, something like that. So 1980. But one personal computer it cost the 2,000 bucks. Really expensive the toy at the time. Then, however, 1990, so it's the price is getting down. Everybody can have the personal computer with the power of what? Network, internet. So internet started from the 1990 and 1991, something like that. So using ARPANET or the ALWANET and something, then the internet is popular. So we can use a personal computer as a part of a computer system. So we downsize. We take out some part of the computer system. Then at that time I joined. So key part is whether we can have as a backend database and application server. It's like the distribution of the transaction, or it's called right now web server is in charge of such the middle part, web application server, like the Apache server, IIS, or such a web application server. Then client is the PC. So we can make the server side backend slim, then the power of some part of the power going to the PC. At that time I joined. as a database designer. So we decide to use the relational database for the backend. Still, we use the same architecture. Still same for the project. So when I joined the database project, my project manager shows the ER diagram. Then he print out all the ER diagram and put on his office work, 3 sides. It's bigger than my office, but much smaller than this one. But still, so 3 sides of the office covered by the print of ER diagram. He said there were 2,000, more than 2,000 entities in one database design, and more than 1,500 the relationship he has in one ER diagram. So it's not possible to use your handwriting. Even you cannot use a PowerPoint, you cannot use the visual, any drawing tool without help of such a modeling tool. So there are a bunch of different designing and the modeling tool. So these are the incomplete list. So among them, still one of the most popular modeling tool is the Irwin software. So Irwin. It's not free right now. At the time it was free. Irwin. So Irwin. So Irwin software. So I'd like to use the Irwin software for your practice. This is just a software. It's not complicated. It's not language. It's just drawing tool. But it have managing entire your project. For example, if you draw the entity student, automatically if you set up the completely, automatically it connect the database and create the table like that. Really. So, but that's not always recommended, but it's possible. So you can even manage such a database using the tool. So we are going to use Irwin software. Next class, you already received the message from the DBA. So bring your laptop, next class, okay? Bring your laptop, then install the Irwin software. Okay, if you go to the Irwin, so we had a license before, but it's very complicated for renewal, so you can use a free trial. So if you go to the data architect, you can download the Irwin software. It's a practice. If you are using MacBook, anyone who are using Mac, so Mac is not always I don't know what happened, so Irwin is not working. So you can install the Workbench. It's a MySQL Workbench. I think that you can check the link from the DBA, the GA, so you can use it. But if you already know any tool from here or even not here, it's totally fine. You can use any ER model designing tool. If you find the simpler one, you can use. Okay? Each and every software using different notation, but intuitively you can understand which one is entity, which one is relationship, and so on. It's not required only Irwin, so you can use any designing tool. But I do not recommend to use the PowerPoint for the practice. Okay, please find such a tool. Okay, any questions? Further, it's very simple. As you can see, just practice. Next. Do you think what is the most popular, the computer science subject nowadays? What do you want to do after you get the degree in computer science? Application developer. Anyone else? So what area are you interested in computer science?
Data science.
Data science. And
Data science.
data science?
Big data.
Big data.
I didn't decide yet.
Oh, you don't have to decide. It's just your preference in the computer science.
I'm not interested in computer science.
Oh, you're not interested? Then why are you taking this class?
I got transferred from India, so I didn't have an option.
Okay. So, what's your major?
Computer science.
But you major in computer science,
Yeah.
but you are not very interested in computer science. Very interesting. Tanya, what are you interested in?
Right now, I'm a lot interested in machine
machine learning, and IT manager. That's also interesting area. So from the management point of view, because it's bigger and bigger. Okay, so big data, machine learning, and management, and also application developer. And I think if you study more and more the computer science, definitely nowadays the most important and the hot buzzing area is the artificial intelligence. That includes the big data, data science, and also the machine learning, and so on. I think that without AI, we cannot survive in the future. So AI was a part of computer science. It's a small part. It's getting bigger. Sometimes it's shrunk, and it's called the AI winter. But it's true nowadays. It's the most important part is of the computer science is the AI, artificial intelligence. So, what is the AI? We try to make the system, machine, intelligent, right? So what is intelligent? Mimicking your brain, right? So we try to make the system like our brain or your brain, like that. Then, which means, so we think about the toddler or even baby, 2 or 3 years old. At that time, do you think that your brain, when you are 2, 3 years old, is smart and intelligent? Probably not. So because of that, your mom and dad taught and trained a lot. So same thing for to computer, whether to make the machine intelligence, we need to do the similar thing. That is called the machine learning or the training. So a lot of such a computer science application or algorithm, even AI, mimic what Homo sapiens did before. So when you learn it's like 2, 3 years old, so if you wanna the baby toddler found this one, then try to eat. But your mom said, no, you cannot eat this one. This is not something to eat. This is for the drawing tool. So don't eat this. But if you find the apple, your mom said this is an apple, this is a food, you can eat. Then next, you may not know because you are 2 or 3 years old. So you pick up the similar thing. Then mom said this is not apple, this is a banana, this is a pear, and so on. So your mom keeps saying why? Because she trained you. So this is apple, and eventually, in your brain, you build a concept of the apple. Okay? Even though you cannot write down the definition, unlike the dictionary. So you know your concept. So round thingy and something, the red color and the shiny, I can eat because it's apple. After you build your concept of apple, if you go to the market, so you never seen the real apple, the apple. This is another entity you never seen, but you know that this is an apple, so you can eat. How? Because you believe, confident your concept. So even though I never tried this one, I know that this is an apple. So a lot of time, the computer science, the professor, researcher, they follow such a concept. So for example, so if we have something entity, apple 1, apple 2, apple 2, we can build the concept of apple. So this is called generalization. So we can generalize from each entity, a number of entities, then build a concept of this entity. It's very similar what we did. Entity, then we can build entity types. It's a generalization. After you build the concept of the apple, when you see the apple, you know this is an apple, this is not an apple. You can specify this is an apple, this is not an apple. So this is called the specialization. So in other words, for example, after you build the entity type, you can create the entity, or in case of OP, object, you can create a class. Using class, you can create an object in the memory. So this is called specialization. A lot of time, it's a generalization and specialization. Bottom up and top to bottom. And also definitely we can adjust. Sometimes it looks like the apple. I try to eat, but it's not an apple. Then you can fix your concept. You can change the generalized concept. It's kind of feedback. It's exactly the same thing when we are doing nowadays machine learning and deep learning and the training module. If not correct, until we satisfy the result, we can keep the changing. It's called sometimes backtracking or feedback, or sometimes think about it's a kind of award system. If you try to eat the garbage or something dirty, so your mom will spank you, right? So it's a kind of award system. So if you are doing good, then give the award like that. So system is the same thing. Machine is the same thing. So somebody says our thinking process is generalization and specialization always. So conceptual modeling is the same thing. Conceptual modeling has such a specialization and generalization process. However, unfortunately, our ER modeling cannot address this kind of specialization and generalization. So people believe to address such issue, so we try to extend ER modeling to the address such the issue, generalization and specialization into the ER modeling. That's called the extended, or sometimes it's called the enhanced ER model. So today we are going to see the ER modeling. Okay. To speed up, let me use the slide this time. So let's take a look at this. So we know rectangular represent what? Entity. So we have employee entity, secretary entity, and so on. Unfortunately, so not all the rectangular are the entity here. So why don't you take a look at the employee? Not this one, this. Employee. So if I cover this part, so employee is an entity, and the name attribute, social security number, birthday, address, job type attribute. And even social security number is a key attribute. So this is one entity, and there is the attribute. So no problem. However, take a look at the secretary, technician, engineer. After you identify the employee entity type, so your customer brought the more data, then when you take a look at such a data, you realize there are secretary. So this is a secretary. There are technician, and there are engineer. Okay, so we identify the attribute of this, attribute of this, attribute of this. Then you realize that secretary is an employee, right? And the technician is an employee, and the engineer is also employed. Do I need to create another entity type, entity type, entity type? Yes, you can do that, but if you create another entity for the secretary, secretary also has a name, social security number, birthday, address, job type, right? It's a conflict. It's a duplicate. Not conflict, it's a duplicate, redundant. So, to address that problem, when you find such a similar or the part of the entity type, we are going to consider all of these employee entity type, one entity. But it can be specialized into the sub-entity. Okay? So secretary is an employee, sub-entity of employee. And the technician is a sub-employee. Engineer is a sub-entity. Okay? So at that time, this kind of relationship is called superclass and subclass relationship. It's not relationship type, it's a super and subclass entity. Okay? So, which means how many entities we have here? Only one employee, but we detail super and subclass. Think about your OP, object-oriented programming, the C++ or What else? Java. You already know this. So we create the one class and inherit. To make the design simpler and developing simpler, we can use the existing, like the person class. Then you can create a student. You don't have to add the same variable for the person. Instead, you can just inherit and create a new subclass. Exactly the same idea for this one. So once you have the employee, then we can have a number of subclasses. So this is called the super and subclasses relationship. It's not relationship type. Okay, don't be confused. It's a one entity. Okay, so this is called the extended ER model. This kind of the characteristic cannot be represented using ER modeling that we discussed in chapter 3. So we are going to add the employee and there. So at the time, there are several important characteristics or property of this. So first thing is how many entity? Only one entity. Okay? These are one employee entity, but it has a subclasses. The secretary, technician, engineer. So at that time, if you do not allow, so which means your employee is a secretary or technician or engineer. Okay, employee should be one of these, not the secretary as well as technician. At the time, that is called the disjoint. So if you have the disjoint, the only one of subclass, you can use the D. Another one is overlap. Overlap allow secretary and technician. That may be possible. There are employees who work for the secretary as well as technician or engineer. If you allow such the overlap, that is the O. O means overlap. So disjoint or overlap. Okay, that's the one thing. Another characteristic is sometimes you can see the single line or double line. Single line means it's always optional. Double line means mandatory. So in this case, single line means optional. Optional means there exists employee who does not belong to anything. So which means only just the employee. However, if you use the double line means mandatory. So employee must be one of these. So that is the full participation. So there are 4 different cases. So by combining. So disjoint and mandatory. Meaning is the one of this. Disjoint overlap. So employee should be at least one of this. It can be multiple. Overlap. Disjoint means the disjoint is the one of this. Okay. The disjoint and the optional means employee does not belong to anything. Okay. Then overlap and the full participation mandatory is it should be at least one of this. Overlap optional means it can be employee only. But if you allow, it can be multiple of overlap. Okay, so 4 different cases. So that is the another characteristic. Definitely, secretary can have all the attributes of superclass because it's inherent. Okay, and the technician also has all social security number, birthday, address, and job type. Engineer also can have the all attribute of the superclass. Then, sometimes if you want to use the classifier of the subclass, like the secretary, technician, engineer is the type of job. So you can create the attribute or you can put such a criteria to the next to the participation the line. Okay, so that is the super and subclass is the extended, the enhanced ER model. Okay. Anything else that I missed? Oh, also, each subclass can have their own attribute. So this attribute, typing speed, is only for the secretary. Okay? And the T grade is for the technician. The engineering type is for engineer. Okay. Then let's try to understand this, the EER diagram. Okay, this is an EER diagram. Okay, so here, first, how many entity type can you find in this EER diagram? How many? First, which one?
Employee.
Employee. This is one entity. Then
Project.
project is the second.
Trade union.
Trade union, third one. How many relationship type? Relationship type.
Two.
Manages and belongs to. Then what about this? This is the subclass of
Super.
employee, superclass, employee entity. Then, very good so far. How many among the employee? This is an employee entity. Among the employee entity, how many super and subclass EER model case? How many super and subclass set can you find?
Two.
2, 3. So first the 2. So first which one? Superclass employee and subclass secretary, technician, engineer. This is the 1. Okay. So take a look at the first one. First the super subclass. Is it disjoint or overlap? Disjoint. Because so which means secretary or technician or engineer. Okay? Is it mandatory or optional?
Option.
Optional, which means there might be employee who does not belongs to anything. That's the 1. The next super and subclasses?
Salaried employee. Hourly.
Salaried employee, hourly employee. This is the second group. Okay? Then, is it disjoint or optional?
Disjoint.
Disjoint, which means either salaried or the hourly employee. Then, is it mandatory or the optional? It's a mandatory, which means the employee should be either salaried or hourly. Okay? So second group. Then we have one more.
Manage.
It's a manager. Why? Because it's a one subclass. It doesn't. We don't need disjoint or overlap because it's a one subclass. Then maybe possible when you are doing the object-oriented programming. When you inherit, when you create the subclass, how many subclass? You can create the one subclass. You can create the multiple subclass. It doesn't matter. It's the same thing. So employee is the superclass and the inherit to the manager. So I know in ER diagram before, we create another entity, okay, for the manager and relationship. That is the difficult thing when you are doing modeling. Modeling is very subjective. Subject to what? Customer requirement. It's not your decision if your customer mentioned. It's not critical. It's not the entity. It's a kind of part of employee. Then you don't have to create another entity. However, on the other hand, if your application manages the manager information separately, or something, the transaction or menu for manager, you'd better create another entity. It's up to you. There's no general solution. But in this diagram, this designer create the one employee, then this is a subclass. Okay, at the time, it doesn't matter disjoint or overlap, but this is optional. It's not full. Okay, some of the employee are not manager. So 3 super and subclass group. Okay, then It's interesting. Relationship type in ER modeling, it can be subclass entity. It doesn't have to be superclass. So you can create the relationship type with the subclass entity. Same thing belongs to. That's another thing. Okay, so pretty much now you can understand the ER model, except one. I do not mention about this. Can you imagine what's the meaning of the symbol? This is called the cup. This is called the cap. You have used this notation in your math class, intersection or union, but it's different here. Can you guess meaning of this symbol? First, you can ignore. It's not critical in our database model. However, this symbol can be used to specify whether this is a generalization or specialization. In this case, the U means, the cup means generalization. In other words, your customer first bring the information about secretary, information about the technician, information about the engineer, information about the manager, salaried employee, hourly employee first. So you identify this separately. Then, as a designer, you realize, so this can be generalized to employee. This can be generalized to employee. This can be generalized to employee. At that time, we can use the symbol, the cup. On the other hand, if your customer brought only employee, then when you take a look at the employee information, you realize there are secretary, technician, engineer, manager, salary, hourly. At that time, you can use the cup. It's a showing thinking process. But in database design, no way to represent generalization and specialization. But it's important in the training model and so on. But here, database design, we can ignore. So you don't have to worry about the notation too much. So this is our superclass and subclasses. Any question? So in your modeling, so project model, so like the phase 2, when you are doing the conceptual modeling for the registration system, we have 5 teams, okay? So in this classroom, the 4 teams, intentionally, okay, on purpose for your practice, create the super and subclasses, okay? It's a 4-year practice. A lot of time when you are doing the modeling, the database modeling, during the designing, you already consider and decompose these kind of super and subclasses into the ER modeling. But sometimes you may have such a case, so intentional, on purpose, why don't you create the super and subclasses, okay? Even though that doesn't really make sense, I try to see such an example, okay? So, a little bit more about the super and subclasses, right? So this is the example of the car and truck. So first, you identify the car, you identify the truck entity type, then you realize that they are anyway vehicle. So you can generalize into the vehicle. Then the ID, vehicle ID, license plate number is a key attribute. It's a common attribute for the superclass, and you can create the subclass. You can see the disjoint because either car and truck. Okay, and also this is a mandatory. So we have disjoint or overlap. Also you can have the total, full, mandatory or optional participation. So this is an example of overlap. So you can see there exists a part. It can be manufactured part or purchased part or both of them because it's overlap. Okay. And also, part should be either this one or both of them. This is the meaning of ER diagram. Okay. At that time, we called this kind of the super and subclass as the kind of tree structure. From the top, we have the parents and children and children. Oh, by the way, what about the engineering manager? This is the subclass of a subclass. It's also possible. You can inherit during the OPIM, the programming. So you can inherit and also you can inherit. So it's also possible. Question, how many entity type can you find in this ER diagram?
One.
It's only one. Okay? It's more specialized. So the subclasses. At that time, so this is called the engineering manager. How many inheritance can you find? 1, 2, 3 inheritance. So like you have 3 parents. The multiple inheritance is called lattice. So it's not critical, but you can differentiate the 3 and 3 is like the hierarchy, but if you have the multiple inheritance, it's called the lattice. So lattice is a generalized case. Okay. I think that we covered the most of the ER model except the union type. So I'm going to explain the union type before we start the ER modeling the exercise on Thursday. So on Thursday, please don't forget hand drawing the homework for the company database ER diagram. Second, your own selected database description and the ER solution, then submit to the Canvas. It can be ER model if you want. So please submit the Canvas. Then the third one, please bring your laptop with the installation of the preferred software. So I recommend for Windows, the Irwin. For the MacBook, you can install the Workbench. So why don't you follow the instruction that sent by the DBF, the GA. Then I'm going to give the coupon code for the GCP next week. Okay. Then you are going to activate the coupon. It's a $50, pretty much enough for your project. Okay. Then because it's a group project, one can be used for training and another one is for the production system like that. But I can give the more credit if you need at the end of a semester. Okay? Don't worry about too much use of the coupon. Then any questions? Okay, we will see on Thursday.